Hey guys, well here we are today in Fusion 360 and we're going to go over our X-axis bearing block cam operations. For the front side, we're going to set up our stock with the top left corner as our XYZ origin. And again, pretty much all of these operations we've done before on the Y and Z axis. We're going to center drill all of our hole locations. Going to come back with a 3/32 and we're going to bore our 4 holes for our bearing cover. We're then going to come back with a 1/4 inch drill bit and we're going to be boring our 4 mounting holes. We're going to be going all the way through. This is a 2-inch thick stock. Next we're going to come back with a 3/16 inch end mill and we're going to do our counter bore for our socket head screws. And then we're going to work on our bearing pocket. Now this is pretty much the same way I did it with the Z-axis. It worked pretty well, so I thought I would just repeat those cam ops. We're going to go all the way through down to our hole that we did in the back side. This will give us a nice clearance hole and a place for chips and coolant to flush through. We're then going to come back and we're going to start working on our bearing pocket with some adaptive clearing. We're going to do this in 2 steps. The first step being 3/4 inch, and then we'll go back down to the final depth, which is about 1.29. We're then going to come back and just kind of clean this bearing pocket up and leave about 4 thousandths. And then we're going to do one pass just to make sure that if we have any tool deflection, we get a nice clean pass for our bearing pocket. And you can use this particular operation to either remove a little more stock or leave a little stock, depending on how your bearing's sizing up. And then last, we're going to be doing some adaptive clearing to clear this shoulder for our X spacer. And I decided to really try to tweak my feeds and speeds. I had a real long discussion with Wyatt, and he clarified a lot of things that I had some misunderstandings with on my chip per tooth, my width of cut, feed rate, RPM, and how it kind of all is related. That stuff can get kind of confusing. I appreciate all the information that Wyatt gave me. I'm making 2 of these, so what I decided to do was do a little experiment with my feeds and speeds. So we're using a 3/8 inch 4-flute end mill. This is a carbide end mill, and our depth of cut is going to be 3/4 inch here. The chip per tooth or feed per tooth is 2.5 thousandths. You want to stay around 1 thousandths to 3 thousandths. So I just chose 2.5 thousandths to see where we were at. The RPMs are going to be 3,000 RPMs at 30 inches per minute. And I left this pretty much the same, and what I did with the 2 different setups is I changed the width of cut 25 thousandths, and I also ran it the first time at 15 thousandths. I was pretty surprised. I think I could go a little bit more, maybe 30 thousandths or 35 thousandths. It seemed to be working really well. So let's go out to the mill and we'll take a look at all these cam operations and we'll run the X-axis bearing block. Hey guys, I'm going to go through these operations rather quickly because I don't want this video to be too long. It's pretty much the same cam operations I did on the Y-axis as well as the Z-axis. So we're going to go through them rather quickly. Alright, now we're going to swap out this and put in a 1/4 inch drill bit, and we're going to drill all the mounting holes. Alright, we've got all the mounting holes bored. Now we're going to come back with a 3/16 inch end mill, and we're going to do our counter bore for the socket head screws. We've got our counter bore done for our mounting holes. Now we're going to start working on our bearing pocket. So now I've changed out the end mill to 3/4 inch length of cut. This is still a 3/8 inch end mill. And we're going to now do our recess here, our shelf for the spacer. I've been playing around with the feeds and speeds on this and the chip load. So let's get going. Well, alright, that turned out pretty good. I thought the width of cut on that was 0.025, twice as much as on the previous version. It still handled it really nice. Probably could go up to maybe 30 thousandths without any problem. The chips were really flying off of that. It's kind of hard to see with the flood coolant, but it was definitely making chips, and it was definitely trying to shoot them off of there. Alright, so let's get it out. We'll get it cleaned up. We'll take a look at it. Alright, well, finished up the X bearing block. Turned out really well. I played around on this recess here for the spacer. I played around with my chip per tooth, my feed rate, and my width of cut. And there's still a lot of room there for me to increase the width of cut, I think. The first pass I ran at 0.015 width of cut, and the second one I ran at 0.025 width of cut. And I really think we could go up to 30 thousandths and even 35 thousandths. It seemed to cut really well, so the finish is fairly nice. This is not a finishing pass, this was just one pass. It did leave a little mark right here, so it probably I could probably come back and just do a a contour or a profile and do a finishing pass on that. But I think it turned out, overall, it turned out really well. It drops right down on there when you get it lined up. So I think overall, pretty happy. I still have a lot to learn as far as the chip per tooth, the chip load, the width of cut, the feed rate, the RPMs, and that'll all just kind of work its way out as I get more experience running this mill. And then I think it'll change some once we get the belt drive going. But I'm going to come back and do some small stuff, bore out and tap out these holes here, and we're going to probably do a video on the bearing cover. I've got to make some of those, and a couple more pieces I need to make, and then we'll wrap this whole mount video series up. Thanks for watching, guys. If you have any suggestions or questions, please feel free to comment. If you're interested in my plans for the CNC conversion, stop by the website. If you're interested or curious about an auto tool changer, stop by and check out my ATC screen set and macros page. Thumbs up if you like the video. Please subscribe. Thanks for watching, and most importantly, be safe.